Hello, I'm Lester Jackson, a senior program manager on the PlayFab multiplayer hosted servers product team.
And I'm Dimitris, a software engineer on the same team.
Dimitri and I will demonstrate how to wrap an existing game server with the PlayFab multiplayer game server SDK and deploy the game server in Azure PlayFab multiplayer servers hosted service. We'll use a Linux build of an open source game named Open Arena, a clone of the popular first-person shooter Quake. Because multiplayer service requires Docker containers for Linux builds, we'll also demonstrate how to build, package, and deploy a Linux container into Azure PlayFab multiplayer servers. Now, Azure PlayFab multiplayer server hosting allows you to operate a dynamically scaling pool of custom game servers in the cloud for session-based multiplayer games. Built on Azure Compute Services, PlayFab multiplayer server hosting helps deliver high performance, high reliability, and low-cost game servers. The massive scale of Azure's public cloud enables dynamic scale, global distribution for lower latencies, and a broad range of compute options optimized for gaming. PlayFab's multiplayer servers handles all the heavy lifting of globally distributing and scaling your game servers out in response to player demand, so you don't have to worry about it, but focus on what you do best, game development. Dimitris is going to take you through a quick demo of building and deploying the Open Arena sample game server. The demo can be completed on a Mac, Linux, or Windows platform, but in our demo, we'll be using a Windows environment. While the steps are straightforward, there are a few key prerequisites to proceed. You'll need to sign up for a free PlayFab account and subscribe to the multiplayer server's premium service using a valid credit card. You won't be charged, however, providing your usage remains under the free 750 free monthly hours, which will not be exceeded for this demo. You'll download the Open Arena sample game server that's been integrated with the gaming server SDK, also known as the GSDK. Now, the Open Arena is a Linux game server. Therefore, to build it on the Windows platform, you need to enable the Windows subsystem for Linux and install a Linux distribution from the Windows Store by searching for the term WSL in the Windows Store. You'll also need to download the free .NET Core SDK to build the sample game server. And finally, you'll also need to download the free Docker for Windows desktop utility to build and run a Linux container image on your Windows environment. Before we jump into the demo, there are 5 key concepts worth mentioning to fully grasp the PlayFab multiplayer server's operating model. Dimitris will demonstrate. Dimitris?
Thank you, Lester. So your game servers can be packaged either in Docker containers or can run as processes, right? So we do support containers on Windows and Linux, and at this time we support processes only for Windows, right? So essentially we want your game server executable. We want also your game assets. This can include game engine files, maps, anything your game server needs in order to operate. This can be packaged either or in a Docker container, or they can attach as assets, right? They can be uploaded to Azure storage. Your game servers run on Azure virtual machines. Those machines are Docker enabled, and they are both. You can use both Windows and Linux. And of course, we support running multiple game servers on a single virtual machine. All of this constitutes a build, right? So a build essentially is your game server packaged, configured to run in one or multiple regions from the ones that we support. Everything you package, you configure on the build, and you upload it either on the playfab.com developer portal, or you can use our application programming interface. Lester?
To run a game server on PlayFab, you'll need to use the game server SDK. And in order to test the integration, you may use the local multiplayer agent. Dimitris will describe these 2 open source components. Dimitris?
So you need to use, as Lester said, you need to use GSDK in order for our platform to understand the health and to manage your game servers, right? So it's essential. For the GSDK, it's a library. We support C++, C#, Java, Unity, and Unreal, popular programming platforms and programming environments. It's open source, and it's very easy to integrate. So you download the library from your programming language of choice, and then you need to implement two methods: the start method and the ready for players methods, right? So the start method both methods actually will start hard beating from your game server to our platform, and the ready for players is used to transition your game server from a standing by to active state. We'll talk about it later. Furthermore, you can use GSDK to log from your game server, and you can get these logs when your server terminates, and you can also get access to configuration settings. When you are done with implementing when you are done with the GSDK integration, you can use an open source developer tool we have called Local Multiplayer Agent that basically will validate if your GSDK integration works correctly. You can use Local Multiplayer Agent to test both Linux and Windows containers, as well as processes on Windows. The tool is open source and very easy to configure.
The quick start demonstration will methodically illustrate 4 key steps. They are integrating the GSDK, building a Linux container image, creating a Linux build in PlayFab, and operating a live game in the developer portal. Once again, Dimitris will demonstrate. Dimitris?
Thank you, Lester. So as Lester mentioned, we're going to use the popular open source game OpenArena, right? So for the purpose of this quick start, we have not modified OpenArena source code to work with GSDK. Instead, we have used the wrapper technique, right? How does this work? So OpenArena actually emits useful status and state messages on standard output and standard error, right? So we have created a .NET Core console application that essentially will start the OpenArena server and then hooks up some events when OpenArena game server emits anything on standard output, right? So our .NET Core console application, basically what it does is it will use GSDK and it will call the relevant GSDK methods depending on the output of the OpenArena game server. Once we're done with that, we're going to create a Docker file. As you know, Docker file are the instructions to Docker daemon to create the Docker image. So essentially, we're going to create a Docker image that contains our .NET Core executable and the OpenArena game server relevant files. Plus, we will make the Docker container image to start the .NET Core application when it starts. And once we're done and we validate that this container image works using Local Multiplayer Agent, we need to upload this image to PlayFab, right? So PlayFab provides access to an Azure Container Registry. There we can use that to upload the container image. After that, we can create the build, and then we can observe the server count and the virtual machines. And in the end, we can use either a PowerShell or an MBS allocator sample to basically allocate a server and test that our game flow is working as expected.
Dimitris, let's please walk through these steps previously described in the quick start overview.
Thank you, Lester. Let's start with our demo. So the first thing we're going to do is visit the developer.playfab.com developer portal, or we call it the game manager. Go to the multiplayer tab. So the first time you go, there will be an enable button. Once you enable the button, you are presented with your current builds, and you can create a new build, right? So on our demo, again, we're going to take the popular OpenArena game and run it on a Linux container on PlayFab multiplayer servers. So the first thing we have to do is clone the PlayFab/nps samples repository. There you can find the OpenArena. And the OpenArena folder here contains our .NET Core executable, which will wrap the OpenArena process, and the Docker file. Let's take a quick look at the code. So the first method that it's been called, what it does is, I mentioned we have already installed the GSDK here via NuGet, right? And the first method that it's called, it starts the GSDK, right? So it's the GSDK.start method. The second method that it's called here will start this shell script. This shell script is from the OpenArena container image. It essentially starts the OpenArena game server. And when this is done, our game wrapper process will hook up to events strings written on standard output and standard error. So this method will handle all the data that's written on standard output and standard error. And when OpenArena emits opening IP socket message, what we do is that we call the GSDK ready for players method. GSDK ready for players method is a blocking call, right? This means that once the code reaches this point, it will halt. At this point, our game server will arrive at a state that it's called standing by. This is a state that it means that we have loaded everything our game server needs to operate, or our game server is hot and waiting for players. Once we allocate a game server, this method call will unblock and our game server will transition to an active state. And furthermore, we have some other filtering here with strings client begin and client disconnect, and we're just adding new connected players via the relevant GSDK method. Also, we have a log message method that will use the log message GSDK to log. So we need to package this executable that we just demonstrated, as well as the OpenArena into the OpenArena game server files into a Docker container image. First of all, we're going to use a .NET Core SDK container image from mcr.microsoft.com container registry to build and publish the OpenArena game wrapper executable. This will have the name OpenArena as it's on the OpenArena folder. And finally, we're going to use an OpenArena image from Docker Hub. There, we're going to copy the OpenArena wrapper executable. We're going to expose the OpenArena port, and at the end, we will tell the Docker container image that the OpenArena executable is actually the root process of the container image. So essentially, when we spin up a new container from our container image, the OpenArena game wrapper executable will be created. As soon as we're done with this, we are ready to build our Docker image. To do that, we need to do something else. We need to go to our PlayFab developer portal and click to create a new build. Why we need to do that? Because we need to tag our container image with the Azure Container Registry that we'll use to publish the image later. To get the Azure Container Registry details from the PlayFab developer portal, we'll create a new build, click Linux, and click Upload to Container Registry. Here, we will find the server URL, which is actually the Azure Container Registry URL that we will use to tag the image. So we're going to use this command. Let me paste it and then I'll explain about it. We're going to go to the OpenArena folder. So we're tagging the image. We are on the OpenArena folder. So essentially we'll use this folder as the context, plus we're going to use the Docker file that we just described. And then we're going to tag the image with the container registry, with a name, and then with a tag. So pressing the enter, it will take a few seconds for the image to build. You can see here that the image was successfully built, OpenArena GDC Live 0.0.2. The actual build took a few seconds because we had already built a relevant image before, and Docker uses a lot of caching to optimize the build process. So we are ready to test the image using local multiplayer agent. So to download local multiplayer agent, we navigate to the playfab/MPS agent GitHub repository. We download the local multiplayer agent. We see the files there. And it's just an executable with a settings file that we need to configure. So let's run it. And there are a bunch of things here we need to configure. First of all, we need to have run container true. Then we need to configure the output folder, which will temporarily store the logs and configuration for the running of local multiplayer agent. Important, we need to configure the game port here with a port that the port we need to test, and the container start parameters. We see here the registry the name, and the image tag is going to be 0.2. Right. So what the local multiplayer agent does is it tests the container, the GSDK integration with your game server process. Right. So the way that it does is that it will spin up a process. It will wait for it to heartbeat. As soon as it heartbeats, it will wait for it to go into standing by state. And after 10 seconds, it will try to transition the game server to an active state. Essentially, it will allocate the game server. But before we go that, let me take a quick break to show you about the game server state. Right, this is essentially the same states we have on playfab.com multiplayer server service. So first states, propping and initializing, are initial states that we use to wait for the game server to load itself. And when your game server calls the ready for player methods, we arrive into the standing by state. Right, essentially, we are waiting for players to request a server. So when your game service or clients call a request multiplayer server, from standing by will transition to active, right? There is a chance that we can transition to terminating when we don't need this game server. But the active state is important because the ready for players call unblocks, completes, right? And players are incoming, and they will join and play their game. When your container process or your game server exits from active, we will go to terminating, right? And on terminating state, what we do is that we grab all the logs that you have that we have from your game server, and then we upload them to Azure Storage that you can use our API to later retrieve them. So once we have the multiplayer settings.json file configured correctly, we are ready to test our multiplayer server with local multiplayer agent. So we will go to the folder that local multiplayer agent is published. And what we will use is use multiplayer agent with the lcow parameter. Lcow stands for Linux Containers Windows. So we will press enter. We will see that it will take some time for it to initialize. We see here that some configuration will be written to OpenArena. And we see here that we have 1 heartbeat every second. And the state, you can see here that is standing by. Right. So if I open another window here and check the running containers, we will see that a new container was created 10 seconds ago that basically serves our game server. And after 10 seconds, yes, we will see that our game server has transitioned to active. Right. This means that the GSDK integration works correctly. At the same time, we can navigate to the folder that we specified as output. We can see here that this has been created, game logs, and we can see output from our GSDK. Right. So again, this folder will contain logs that will then be hosted on Azure Storage, and then you can use the MPS APIs to retrieve the logs. So our game server is working perfectly. Everything is set, so we can take the game server and upload it to the Azure Container Registry so we can use it from our build. So we'll go back here. And for the Azure Container Registry that we create, that Playfab creates for you, you need to log in, right? So you copy this login command, which is basically docker login -username and -password. We have run it. And then what we need to do is use the docker push command to basically upload the image onto the Azure Container Registry. So we'll wait for it. The image was already uploaded, so the upload took a few seconds. And if we go here and we select the image, we will see 0.2 tag exists, which was just created. We're going to have a name for our build, game test. We're going to select one of the recommended virtual machines. And here is a very important drop down that we specify the number of servers per machine, right? This is essentially how many containers we want to run on each virtual machine. Optionally, we will include some assets. Optionally, also we can override the start command we have on our Docker file. And here we need to add region. So we can select here some of the regions that you have quota to select for your build, right? It's very easy to manage quota. You have to go to we may show it later. And then there are two important settings that we need to configure: the number of standing by and the number of maximum, right? So Let's take a step back and think. So when you create a virtual machine, when you create a build on a region, right, PlayFab will try and create standby servers for you on the virtual machines, right? So right now we say to MPS that we need 5 standby servers all the time. So we need 5 warmed up servers ready to accept our players, right? So these servers are in standing by state. Once we allocate one, we'll have 1 active and 4 standing by. At this time, since we want 5 standing by, PlayFab will create another container for you so to reach the level of 5 standing by, which is what you asked. But at any given point in time, the number of standby plus active will never be more than the max, right? So this is essentially a tool to protect your wallet, right, by not having more than maximum servers created at any point in time. Moreover, more importantly, we need to select the network port that our game accepts traffic. So for OpenArena, it's 27960. Oh, sorry, I have to put it here. Here we have to give a name. I'm gonna just call it game port. OpenArena is using the UDP. You can add certificates here to the build in case your game server needs to authenticate with a protected resource somewhere. You can also add custom metadata in case you want to add special details about this build. This metadata is easily retrievable via GSDK. Once we're done, we take a quick look that everything looks as expected, and we can click Add Build button. So we go back to our builds. It will take about 5 minutes for this build to be deployed. However, we have deployed another build so we can test, right? But before we check the build, it's very useful to go on some of the states of the build, right? So first of all, if you recall, each build has one or multiple regions, right? So each region goes from initialized state, then goes to deploying. Hopefully, if everything goes well, which means that we get the necessary VMs and we spin up the game servers you asked, the specified amount of them, everything works, we will reach the deployed state. If something goes wrong, the build will reach unhealthy state, right? And of course, at any point, we can delete one or more regions from a single build. This is for the status of each region. The status of the build actually is determined by the status of all regions, right? So if at least one region reaches unhealthy state, then the entire build will reach the unhealthy state, right? But hopefully everything will work well, and from the deploying state, we will reach deployed, right? And at any point in time, we can add or delete regions. If we delete a region, we will go to the deleting region. If we add a region, it will go to the deploying state again. And last but not least, we can delete the entire build. Last but not least, it's very useful again to talk about the game life cycle, right? So to recap, in the beginning, you create your multiplayer server, you integrate it with GSDK, right? You upload it on developer portal or via API, and then you scale it. Then before you request a multiplayer server to allocate, to send players to, it's useful to measure the latency, right? So we have what we call a QoS service. So we have some UDP beacons deployed to all the data centers in the world that we support. And there, your matchmaker essentially can send a UDP echo and then count the number of milliseconds the response will be back, right? So essentially you want, for example, players in Europe to connect to European data centers. You want players in America to connect to the American data centers. The less the latency, the more pleased the better the experience your game players will have playing your game. Once you determine your region, then you can request a multiplayer server and then you can send players on it. So let's go back to the build. So we're gonna play with the OpenArena GDC build. Its build has a build ID, which is a GUID. So to allocate a game server, we can use multiple ways. First of all, we can use the API. For quick developer purposes, we can use the MPS allocator sample, which is also bundled with OpenArena and other samples on the MPS samples repository. But for this demo, we're going to use the PowerShell, the newly released PowerShell modules, right? Which essentially is an extension to the cross-platform PowerShell command line utility to interact with multiplayer servers using the API. It's very, very easy to install and configure. So when we use them, first we need to authenticate. We have already done that, calling a setpf title. And now I'm going to call getPF build, which will give me all the builds that I have on my system. So we have the OpenArena GDC build, and we have the game test build that it is deploy state. We'll use this one. And then the next, we can get build information for the OpenArena GDC build. We can see here that the build has 5 standing by servers and 5 in total. And now it's time to allocate a game server. Right? To allocate a game server, we're going to use this command. So the API is called request multiplayer server. So we provide the build ID. Right? Each game server requires a session ID, which is uniquely tied to for the duration of its lifetime. So we provide a session ID, which is a GUID. And then we choose to allocate, the preferred region to allocate is West US. So as soon as we request a multiplayer server, we will see that we got back details from this multiplayer server, which is an IP address and a port to connect to. Right? So at this point, we are ready to test the game. However, before we do that, it's useful to explain how this port is created, right? Because you may recall that the actual game port is 27960. So I'm going to show you this diagram, which is actually the last diagram. So these are game server instances created on the local VM, right? So you can see here that, for example, this game server has 3600 UDP port configured, right? So when we spin up these game servers as Docker containers on the virtual machine, there is a mapping on some ports on the VM with ports on the game server, the game servers itself, right? So you see here each container has its own IP address. So you can see here that 30,000 on the VM is mapped to container 1 port, 30,001 container port, and etc. etc. And this port has actually, there is one other level of mapping. We have an Azure load balancer that basically is the bridge between the Azure data center with your game servers and the internet. And the mapping here is that these UDP ports on the load balancer are mapped to the ports on the VM. That's how we create a new port for you every time you request a new multiplayer server. So now it's time to test the game. Lester, you want to try playing the game together?
I'm happy to do so. Why don't you share with me the connection details, IP address and port, please?
Of course. So the way we can get them is that if we request multiplayer server with the same session ID, we'll get the same details back. But the preferred method is to use the get multiplayer server details, but passing the session ID parameter and, of course, build ID and region, and then we will get the connection details back. So I'm going to copy paste the IP. The port is 30100, and I'm going to open the OpenArena executable. We go to multiplayer option. We're going to specify a custom server. I'm going to paste the IP we got, and we're going to do 3130100. And in fight, we will join the server. We see here that we are playing the game. We see here that Lester just joined, and we see that here we have a very small ping, and I just lost. Okay. And we're going to exit game. So coming back to the developer portal, we can see that OpenArena GDC build has 1 active server. We can easily see some details here, our remaining quota. We can modify target standby and the maximum. We can go to virtual machines tab. If we need to debug something, we can easily connect to the virtual machine, getting SSH connection information here, and getting a password. These users are temporary. Every time you click connect, you're gonna be presented with a new user. So we can go here. We can run Docker PS to see the running containers. We see here that we have 5 containers per machine as we configured when we're creating the build. We can also see logs from a Docker container, Docker logs, and then container ID. We can see here the logs, everything the OpenArena server sends us. We can run pop command to see our CPU usage. We can do everything we do on a normal Linux system if we want to debug. Going back to the developer portal, we can see here the status of our server. 1 active, 4 standing by. And then we can see here total usage, which is basically the usage in cores that we have done over the last period, over the last 7 days, or the last 30 days, or any period we want to select. And then we can use the quota item so we can manage our game server quota on regions. That's it from me, Lester.
Great job.